Hi guys. Part 1 of these 3 different videos posted was a review of the Quadratic Functions unit. I do suggest that you spend 18 minutes of time looking through that. I think it's just sort of like a good overall perspective of the concepts and skills required within the unit. Of course, it doesn't go into the depth of applying them into real-life situations, but we'll get a chance to do that in some of these review questions. So let's work on number 1. We've got a graph of a quadratic function. You can see how it forms the shape of a parabola, and it's given in standard form, y equals x squared minus 2x minus 3. Now, if you watched the video just now, I'm sure you'll remember that the negative 3 must represent the y-intercept. And so we know that we've got a y-intercept right here at negative 3. And we would have to put it into factored form if we wanted to find the x-intercepts. Now I know it appears that they occur at negative 1 and positive 3, but this is just a general thing for the course. Don't assume that a diagram that has been drawn perfectly accurately for you. There's many diagrams that are not drawn to scale, and so you just have to be careful not to make assumptions that this would go through at exactly negative 1 or exactly positive 3. We can also see a vertex. It might occur with a x value of 1, but we certainly can't be sure. Alright, let's have a look at the question. It says to draw the graph of y equals 5 on the same axes. Now, we just recently talked about how an x equals would be a vertical line, okay, if you had an x equals. So a y equals must be a horizontal line. So where is y equal to 5? Well, if this is 0 and this is 10, y equals 5 is obviously right in between. So we draw the line, I suppose, right along here. And of course, I should use a ruler, because IB sometimes can deduct a mark if you do not use a ruler. So if you don't have a ruler, please use the edge of your student ID card, or even the edge of your calculator. Alright, part B, use your graph to find the values of x when x squared minus 2x minus 3. You remember that this thing is the same as this thing. So this thing right here, it represents the parabola, while this thing right here, the 5, that's your other thing. It's a little bit like putting your y1 is your quadratic function and your y2 is your constant function. Where are these y values equal to one another? In other words, where do the two different functions that we've got on the graph, where do they intersect? Now, according to the graph, and it does say use your graph to find, it appears that these intersections occur. It says the values of x only. I don't need to give the value of y. So the values of x appear to be at negative 2 and at positive 4. Of course, we could use our calculator to verify this. So we could put in as our first function x squared minus 3x, minus 2x minus 3. And our second function is y equals 5. And then we could graph, and we could press second calc intersect to find out, that's option 5 by the way. Our first curve, yes, is x squared minus 2x minus 3. Our second curve is, yes, 5. And we need to guess. That just means that we need to sort of let the calculator know which of the two intersection points I'm looking for. I'm going to take a guess. I could either move the cursor there, or I could just put it in. I think the guess, maybe I'm going to say I'm guessing at negative 3. In fact, the intersection occurs when x is negative 2, just like we got manually. And I could do this again to get the intersection between that curve, and this time I'm going to guess a value of 4, and look, I was right, it does occur when x is equal to 4. A third way, I suppose, would have been to bring the 5 over to the left-hand side, where we'd end up getting an x squared minus 2x minus 8. And on the right-hand side, there would only be a 0 left. And when you have a 0 left, you can either factor, and now we can see that our values are going to be at positive 4 and negative 2, or you could have used Poly-Sumilt. And so, just a reminder of Poly-Sumilt. Oops. Oh boy, I don't know what I've got into. Quit. Quit. Boy. Alright, looks like that's quit. Go into polysimilt. And we'll go to the polyroot finder, which is option 1. And we've got a second degree equation, because it's a quadratic. And our values are a, the coefficient of x squared is 1, coefficient of x is -2, and the constant at the end is -8. Once you've entered those three coefficients, it will solve and tell you that we've got values of +4 and -2. Okay? Alright, part I, the value of x that gives the minimum value of, you remember that this is the quadratic function that we had right at the very beginning. So that's the parabola. Where is the minimum value? The word value means the y value. So what is the minimum y value when I get to the bottom of this parabola? It's tough to tell by the graph, especially because we know that the graphs are not given to scale. So maybe we should use the calculator to do this. Remember that we were dealing with, quit. Let's look at the graph again. Where is this minimum value? So I'm going to say second graph minimum. Not certain what's going on here. Let me think. Maybe it's because I've got two functions in. Is that what it doesn't like? That's a little strange. Let's get rid of that function. Sorry, I haven't seen this before. Maybe minimum only works when you've got one function entered. Now let's try second calc minimum. Oh, that's what I was expecting. So we'll move our cursor to the left side of the minimum. There we go, it's flashing on the left. And let's move it to the right side of the minimum. As you know, alternatively, you can just type in x values. And then we'll guess. I'll move my cursor fairly close to that intersection point. Press enter, and it shows us that the vertex occurs. Now we need to know how to interpret our calculator values. 1.000006, of course, that is simply x equals 1. The y value is not relevant here because it's only asking for the value of x that gives the minimum value. So it turns out that in this case the graph actually was accurate, but you shouldn't have assumed so. Much better to use your calculator or some other method in order to find the vertex there. Another way that we could have used it would have been, you remember that the axis of symmetry goes right through the minimum value or the vertex. So we know that the axis of symmetry has an equation of x is equal to -b over 2a. In this case our b is -2, so the negative of -2 divided by 2 times the a value of 1 will give me 2 over 2, which is equal to 1. So that's another way I could find the x value at the vertex, because the x value of the axis of symmetry is x equals 1. Alright, let's move on to the next question. We've got a diagram of an upside-down parabola. No surprise it's an upside-down parabola because we've got a negative value in front of the x squared term. Probably I would immediately rewrite that expression. That's a little uncomfortable for me. I would rather have the quadratic term first, then the linear term, and then the constant term, which is a positive c. Alright, here we go. Let's find the values of k and c. You might remember that when we've got a quadratic function that's been expressed in standard form with no parentheses, the c value is the y-intercept. Let's look at our graph. What is the y-intercept? It's right here. Clearly at the y-intercept, y is equal to 0. And that must mean then that the c value is equal to 0. So actually we're dealing with a quadratic function, -x squared plus kx plus 0, which I'm not going to bother to write down for the rest of the question. Now we need to find the value of k. What other information do we have about this parabola? Oh, I can see that the value 5, 0, this point, this coordinate, exists on our quadratic function. So that must mean that it satisfies this equation. That is to say that when x is 5, y must be equal to 0. So let's put in then a y value of 0 when x is equal to 5. And now let's solve for our value k. The 5 squared becomes a 25. If I move it to the left, it becomes a negative 25. K times 5 is, of course, 5 times k. Let's divide both sides by 5, and we'll find then that k is equal to negative 5. Part B. Let's find the coordinates of Q, the highest point on the graph. Well, the highest point on the graph is the vertex, isn't it? And we know that the vertex occurs on the axis of symmetry. We know that the axis of symmetry occurs right at the middle of our two x-intercepts, which are occurring at x equals 0 and at x equals 5. So our x value of the vertex must occur exactly at the midpoint of these two x values. So that x value will be 0 plus 5 divided by 2, which simply equals 5 over 2. Now that's the x value. In order for me to find the y value, I'm going to have to substitute it into my equation. So my new equation, remembering that my c value is equal to 0, and that my k value is equal to negative 5, so plus k becomes plus negative 5 or minus 5. Let's substitute in the x value of 5 over 2 in for my x values. Now, if this makes you a little bit uncomfortable, I know that some of you might prefer to reach for the calculator at this point and use 2.5. And so we can say then, what is it when you get then, let's quit the graphing screen and say, what is the negative of 2.5 squared minus 5 times 2.5? We get a value of negative 18. Oh, let me pause for a moment and think what the heck just happened. That surely shouldn't be right. I can see that my y value should be a positive. What have I done wrong? Alright, I better have a I guess I should have a look at this a little bit later on. I haven't figured out yet my mistake. Oh, shoot. Now, I just saw it right before I paused the video and everything. I missed this negative sign way back here. It must have been driving you crazy the last couple of minutes. So sorry. Let's get that figured out. So this was supposed to be a negative of 5 squared. So that was supposed to be a negative 25, and when it comes to the other side it becomes a positive 25, so k was equal to positive 5. Ah, shoot. And so this was a positive 5, that's a positive 5. Let's go back to what we had in the calculator. By the way, I guess I could try to find some positive in this mistake by showing you a little neat feature. You see right above your enter button, you've got this thing called entry. If you say second enter, it immediately puts in on your calculator the last thing that you entered. And that's useful when you're going to put in an expression that's very similar to the last one that you just had. I'm just turning this into a positive 5 times 5 over 2. And then I see I get an answer of 6.25. So the coordinates of Q then are 2.5 and 6.25. Going on to question number 3. Here's our graph of just a regular parabola, y equals x squared. And now we've got some transformations on the graph of y equals x squared. It's been moved upwards, it's been moved to the right, and it's been moved upwards and to the right. We need to write down the equations of these three graphs, diagrams 2, 3, and 4. So compared to our original diagram, we can see that the vertex, which used to occur at 0, is now occurring 3 units upwards. You might remember that in order to represent that our y coordinate is 3 bigger than it used to be, then y is equal to x squared plus 3. So when we see a constant that's being added, that means that we're moving upwards. Or if the constant is being subtracted, we're moving downwards. Let's move on to diagram 3. This time we've moved to the right. Now, I might have mentioned this earlier, but we know that we do the opposite of what we expect when we are moving horizontally. And so instead of us moving positive 2, we're actually going to say x minus 2. So anytime that you're dealing with something that's got to do with an x, you've got to do the opposite of what you expect. And that must occur inside the parentheses to indicate that it is a horizontal transformation. I know that a lot of students have written down this. They'll say it's x minus 2, and then they'll write the square here. That's incorrect, because this would indicate that we are sliding downwards by 2 units. So the square must appear outside of the transformation to show that the transformation is occurring in the horizontal direction related to the x coordinates. Diagram 4 has done both of these things at once. Not only did we move to the right by 2 units, which I know I indicate in that manner, but I've also moved upwards by 3 units, and I know that I indicate that in this manner. And there's the answer to number 3. Question number 4. The graph of a quadratic function intersects the horizontal axis at 1, 0, and the equation of the axis of symmetry is x equals -1. Now, if your first instinct is not to draw a diagram of the situation here, you need to acquire a better first instinct. That's a lot of words, and it will really help us to see a picture of what's happening. I have an x-intercept at 1, 0. And I have an equation for an axis of symmetry at x equals -1. I know that an equation of an axis of symmetry is a horizontal line that represents the middle of a parabola. So if I've got an x value out here 2 units to the right of that equation of the axis of symmetry, well then surely my other x-intercept must be 2 units to the left. So if this was -1, that must be -2, -3 must be the location for my other x-intercept. And indeed, that is what it's asking for. It wants the x-coordinate of the other point where the graph intersects the horizontal axis. And there it is, -3. Then it tells us that the function reaches its maximum value. It reaches a maximum. That must mean it climbs up to the top, the maximum before falling. It is going to be an upside-down parabola, looking something like this. And it says that it reaches a maximum value at y is equal to 5. What is the value of the function, which is our quadratic, right? Our quadratic is the function. What is the value of the function at -1, right? This is f at -1, or f of -1. The -1 is the x value. So, what is the value? Remember, the word value means the y value. It's saying, what is the y value when, in the function, the x value is -1? So let's look for our x value of -1. What is the corresponding y value? Oh, 5. And so our value is 5. The question's really just asking whether you can correlate this information, the maximum value at y equals 5, along with the axis of symmetry at -1, to figure out what your y value must be at that axis of symmetry, which is, of course, your vertex and your maximum value. Question double I is to find the range of the function. I hope you remember that range represents all of the possible y values, just like domain is all of the possible x values. Here it's only asking for the range. What are the possible y values on this range? If you had to describe all of the different y values, we've seen one different method is to scrunch or squish everything on our function over to the y-axis, because of course I'm looking for my range, which represents the possible y values. What values of y have I covered along here? Well, my covered values of y are everything less than or equal to positive 5. So all of my y values in the range are less than or equal to positive 5. Okay, we'll have a look at the solutions to the last 4 questions on the next video.